Welcome to The Explainer. Today, we're diving into the science of how your students actually think and learn, all based on the fantastic research of Dr. Sudhandra S.G. We're going to peek inside the machinery of the mind, and the goal here is simple, to help you become an even more effective, more insightful educator. Okay, let's jump right in with a quick puzzle. A bat and a ball cost $1.10 total. Here's the catch. The bat costs exactly $1 more than the ball. So, how much does the ball cost? Go on, take a second. What's that very first answer that just popped into your head? Now, if you thought 10 cents, don't worry. You're in very good company. That's the answer that just feels right, doesn't it? It's immediate, but the correct answer is actually 5 cents. Think about it. A 5-cent ball and a $1.05 bat adds up to $1.10. So the big question is, why do so many really smart people confidently make that same initial mistake? The answer to that is the key to understanding your students. So here's our game plan. First, we'll unpack that confident mistake. Then you're going to meet the two characters in our minds responsible for this whole thing, Gun and Drew. After that, we'll explore why real thinking can feel so darn hard, how to wake up what we'll call a lazy brain, and we'll wrap it all up with some practical strategies you can start using in your classroom tomorrow. All right, section 1, the confident mistake. You've seen this a million times in your classroom, right? You ask a question, and a super bright student blurts out an answer that is immediate, it's confident, and it is completely wrong. You know, this has nothing to do with intelligence. It's all about how the human brain is wired. So what's going on here? Well, the secret, as psychologists tell us, is that we don't just have one single mind. Instead, it's more like we have two competing systems of thought, and they're always at work, often pulling us in totally different directions. Let's meet them. To make this super easy to remember, we're going to give these systems names. Let's call them Gun and Drew. I want you to think of them as the two little characters inside every student's head and, by the way, inside your own too, directing the show. Okay, so let's break them down. Gun is your gut reaction. He's fast, he's automatic, totally intuitive. He operates without any real effort at all. Drew, on the other hand, is the complete opposite. He's our slow, deliberate, logical thinker, but, and this is crucial, he's also incredibly lazy. So, back in your classroom, Gun is that student who shouts out the quick math answer without thinking. Drew is the student who painstakingly writes out every single step to check the work. And in our bat and ball problem, well, Gun yelled 10 cents, and Drew, being the lazy guy he is, just kind of shrugged and went, sounds good to me, without ever bothering to do the actual hard math. This brings us to a really important question. Why does that real, deep, effortful thinking feel so hard for our students and for us? Well, the answer lies in the built-in limitations of Drew's workspace. Our working memory, and you can just picture this as Drew's tiny little office, can only handle about 4 or 5 new pieces of information at once. That's it, just 4 or 5. So you can see why when a student faces a brand new multi-step problem, they get completely overloaded, almost immediately. So how on earth does the brain get around this major bottleneck? The answer is a really clever process called chunking. This is basically the brain's genius strategy for bundling up familiar bits of information into a single package, so it only takes up one slot in that limited working memory. This frees up a ton of space for new learning. I mean, think about it. When a student first learns long division, every single step, divide, multiply, subtract, bring down, it just swamps their working memory. But with practice, all those steps get chunked into one smooth, automatic process. It's the same thing a musician does playing a scale or what an expert driver does navigating heavy traffic. All those little details become one fluid motion handled effortlessly by good old Gun. Okay, so if getting to that automatic, chunked state is the goal, how do we get there? It all comes down to waking up that lazy part of the brain. We have to find clever ways to force Drew to get off the couch and actually do some heavy lifting. C. Our brains are fundamentally wired to save energy. which means they always prefer comfort. It's why students love to just reread their notes. It feels easy, it feels familiar, but real durable learning only happens when we force Drew to engage with what are called desirable difficulties. These are tasks that are challenging, yeah, but are ultimately achievable. And this is backed up by some truly fascinating research. In one study, scientists gave students some tricky problems, but for one group, they printed the problems in a blurry, really hard-to-read font. And guess what happened? That group's error rate dropped dramatically. That difficult font was like a little alarm bell. It slowed them down, it silenced Gun's instant guess, and it forced Drew to wake up and actually think carefully. This is so important. It means we, as educators, need to completely reframe how we think about confusion in our classrooms. It isn't a sign of failure. It's actually a signal that the brain is wrestling with something new, that Drew is finally off the couch and engaged. You could even say that confusion is the feeling of learning. Okay, so this is all great theory, but how do we put this science to work? What does a classroom that truly understands the dynamic between Gun and Drew actually look like? Let's get practical.
Well, first, we have to embrace that discomfort. Let students know it's okay, even good, to be confused for a bit. Second, we have to design lessons that make Drew work. Things like debates, puzzles, and real problem solving, not just passive lectures. Third, we build those chunks of knowledge, moving from guided practice until skills become automatic. Fourth, we test. We don't just reread. Low-stakes quizzes force active recall, which is way more powerful. And finally, we normalize mistakes. We can frame them as Gum's first guess, not as a student's failure.
This approach is absolutely essential for tackling deep-seated misconceptions. Gun loves simple, intuitive ideas, even when they're flat out wrong, like that age-old belief that heavier objects fall faster. It doesn't matter how many times you tell students the correct principle. Unless you force Drew to engage with experiments and reasoning that directly challenge that wrong idea, Gun's bad intuition is just going to keep on winning. When you really think about it, this represents a fundamental shift in our role. Our job isn't to eliminate struggle or to make learning feel effortless. Our real job is to be architects of challenge, to design experiences that are just difficult enough to engage Drew so that Gun can eventually take over with the right knowledge and the right skills. And that really leaves us with this final, powerful thought. The science of thinking shows us that confusion isn't some barrier to be avoided or something we need to fix immediately. Confusion is the very path we must guide our students down if we want them to achieve real, lasting, and much deeper learning.